When you're graphing reciprocal functions by hand or doing a sketch on paper, it's very helpful to sketch the denominator function, the quadratic in this case, or if it's a linear function, the linear function, on the same graph. If you can understand what's happening to the denominator, then you can understand what's happening with the reciprocal function. So when I approach this function y equals 1 over x squared minus 2x minus 3, I want to know what the function on the bottom looks like. So that function is y equals x squared minus 2x minus 3. So if I'm going to graph that quadratic, I'd either like to factor it if I can, or put it into vertex form. And this one factors quite nicely as x minus 3, x plus 1. And that allows me to identify the zeros. So this has two zeros, one at 3 and one at -1. And because it's got a positive leading coefficient, I know it's facing up. And so now I can sketch the quadratic. And once I have the quadratic sketched, then I can understand the reciprocal function much better. So the quadratic, x squared minus 2x minus 3, is facing up, crosses through at -1, and then at 3. So wherever the quadratic is 0, the reciprocal function is not going to exist, and in fact it's going to have a vertical asymptote. So I can put a vertical asymptote going right through those zeros of the quadratic function. That's going to help me sketch the reciprocal function. And on the left, you can think of the reciprocal function as having 3 branches, right? Divided essentially by those vertical asymptotes. We're either to the left of the first vertical asymptote, we're either between the two asymptotes, or we're to the right of the rightmost vertical asymptote. And on the left, the quadratic is positive, and so the reciprocal function is going to be positive. And if we go far enough to the left, we're going to be getting closer and closer to 0. So it's going to be coming along like that, and then swooping up or blowing up at as we get closer and closer to the vertical asymptote, because you're taking in every case the reciprocal of the quadratic, and as the quadratic gets closer and closer to 0, the reciprocal gets larger and larger. Now we've got exactly the same behavior on the far right hand side. So if we're just a tiny bit to the right of 3, the quadratic has values that are very small positives, and the reciprocals of that are very large. And so this is coming down from positive infinity and then heading out along the x-axis, almost parallel with the x-axis. Now, in the middle is where we have something a little different from what we saw with the reciprocals of linear functions. It's helpful to identify the vertex. The vertex is going to be halfway between the zeros, and so halfway between -1 and 3 is 1. So let's identify this point right here. It's got an x-intercept of 1, and then we can take that, not an x-intercept, an x-value of 1, and we can take that x-value of 1 and plug it into x squared minus 2x minus 3, or plug it into the factored form, whichever way you want to do it. If you plug it in up here, you get 1 squared minus 2 minus 3, or alternatively you get 1 minus 3 times 1 plus 1, and either way you get -4. So the y value of the vertex is -4. Now that helps us understand the maximum value of the reciprocal function. The reciprocal comes up from -infinity, and these loops have they don't look rounded like a parabola. They're very kind of blunt or fat, if you like, and they sort of flatten out on top, and then they plunge when you get close to the asymptote. And their maximum point is going to have the same x value, 1, and the y value is just going to be the reciprocal of the y value of the vertex. So in this case, the reciprocal of -4 is -1/4. So now we've got everything we need to describe the domain and range. The domain of the reciprocal function is all x values except for -1 and 3. The range, well, the branch on the left and the branch on the right start from 0 and go up towards positive infinity. The branch in the middle is the one where you have to be careful. The branch in the middle goes down towards negative infinity, but it only goes up to that point that we identified, which has a y value of -1/4. So it's all y values less than or equal to -1/4. And then, as I said, the two branches on the right and left are all the positive y values. So it's more than just missing the y value 0. We saw that with the reciprocal of linear functions. We just had a single y value that missed, that we didn't have. But here there's a sort of a thin sliver, if you like. Not only do we not have a y value of 0, but we don't have a whole bunch of negative y values in between 0 and -1/4. Now, the asymptotes, we have 3. So we have the two vertical asymptotes, x equal to -1 and x equal to 3. And then we have the horizontal asymptote that all of our reciprocal functions have, whether they be reciprocals of linear functions or reciprocals of quadratic functions, and that's y equals 0. And so that gives us a nice sketch, and it gives us the descriptive information. Let's take a look at another one. What if we're trying to graph y equals 1 over x negative x squared minus 2? Again, I want to start by thinking of the denominator, minus x squared minus 2. Now that is a quadratic, or a parabola, that's facing down, and it has a vertex at 0, -2. So I can do a sketch very quickly, because I know this comes up and goes back down again without ever crossing the x-axis, and the point, the vertex, is at 0, -2. And so, actually, let's go back and be consistent here and do that in red so that we don't get confused. Okay, so that's the quadratic in red. That vertex there is 0, -2. Now, when I go to graph the reciprocal function, well, on the far left, I'm taking the reciprocal of values that are a long way from 0, but they're negative. So they're going to be getting very close to 0 and negative. And all that's going to happen is a tiny little dip. And then it's going to head right back up again towards the x-axis. So that little dip is going to correspond to the vertex, the maximum value of the parabola. And the y value is simply going to be the reciprocal of the y value of the vertex. So the reciprocal of -2 is -1/2. So it's a very sort of boring, if you like, reciprocal function. Doesn't really do a whole lot. There are no gaps. It's a continuous function, so there's no vertical asymptotes. The domain is simply all real numbers. The range is very narrow. It's a very narrow band. It gets all the way up to 0, but doesn't ever actually hit 0. And it goes down to that minimum point there at 0, -1/2. So it's all the values from -1/2, including -1/2, so -1/2 less than or equal to y less than 0. So when you're writing, remember when you're writing intervals, usually you want to write the numbers in the same way they'd appear on a number line. So that's why I started with the -1/2 and I finished with the 0. and the range is all the y values between -0.5 and 0, including -0.5 because I got that point there, and not including 0 because it's never going to get up and touch 0. There's only one asymptote. There's no vertical asymptote, so we only have the one horizontal asymptote, as always, y equals 0. Okay, let's take a look at one final example. In the last section we talked about the three cases, one where you have 2 zeros for the quadratic, one where you don't have any, and the third case where you have just 1 0. So what if we have a reciprocal function like this, y equals 1 over x squared minus 6x plus 9. So again, I want to know what the denominator looks like. X squared minus 6x plus 9. That factors as x minus 3, or x minus 3 squared if you like. And that means that there is only 1 0, 3. So when I go to sketch the function, the quadratic comes down, touches, and goes back up again. And that point there is at 3, 0. Now, it is a 0, which means that the reciprocal is not going to exist at that point, and as with all the other zeros, we're going to get a vertical asymptote. And it'll go right through that 0. On the left, the parabola is positive, and so the reciprocal function is positive. And we've seen this sort of behavior before. On the right, just the mirror image. And so we end up having no negative values here whatsoever because the parabola never goes below the x-axis. When the parabola touches the x-axis, the reciprocal doesn't exist, and everywhere else the parabola is positive, so the reciprocal function is positive. And when you get close to that 0, the reciprocal function blows up. When you get far away from that 0, the reciprocal function gets closer and closer to the x-axis. And so the domain is simply all values of x not equal to 3. The range, well, we don't have anything below the x-axis, and we have all the y values above the x-axis. So it's y greater than 0. The asymptotes, we have one vertical asymptote at x equal to 3. And as always, we have the horizontal asymptote y equals 0.